In lesson 35, we start with factoring the greatest common factor. We touched on this with that little extra video clip yesterday, the previous lesson. When we got into the why they were given these things to us as addition or subtraction problems, when they were only asking us for the greatest common factor. Today we find out why. If we wanted to look at these two terms here, excuse me, and factor them, what we're trying to do is really factor something out. We're trying to pull something out of both of these terms. In other words, we're going to find something they're both divisible by. And we could do that. We could say, well, we could take a 2 out of both of these. You could pull a 2 out of both of these, and you'd end up with 2 times ax plus ac, and that is absolutely true. If you divide both these terms by 2 or factor the 2 out, you'd get a 2 times ax plus ac, and we could reverse that and distribute it back through, and we'd end up with what we had to begin with, right? But oftentimes we don't want to just pull a 2 out or a common factor. We want to pull out the greatest common factor. The greatest common factor that we can pull out is not 2 but 2a, and we could do that by, this is about as simple as it gets, prime factorizing. 2 times a times x is the first term, 2 times a times c is the second term. What do they have in common? They have a 2 and they have an a. So 2a is the greatest common factor, so we don't want to pull a 2 out but pull a 2a out. And when we do, we have 2a. It'd be kind of like, or exactly like, dividing by 2a. They cancel out. What's left? An x plus, it's dividing out a 2a. What's left? A c. 2a times the quantity x plus c. We could have looked over here to see what was going to be left. X and a c in those two terms. And again, if we reverse this back and distribute it back through, we'd end up with what we originally started with, 2ax plus 2ac. So we don't want to just factor something out, we want to factor out the greatest common factor. Another example, here's an expression with 3 terms. And we could find the greatest common factor of all of these by writing out, change colors here, a times a times a. I'm only going to do this once. We're not going to do this for all of them. But here's the first term. Here's the second term. This is what we did yesterday. We're going to try to find the greatest common factor of these. The third term. And now we circle those in common. A, another a, an x, not another one, but we got an m, and we got a second m. So our greatest common factor is a squared x m squared. And instead of, we're going to write this out this time, but not anymore, because we really got to start to understand the greatest exponent on the a has to be the smallest of the 3. Because if they have to have it all in common, it has to be the a squared, doesn't it? Just logically. We could never get it beyond that or above that. And it is, it's a squared. The greatest exponents, the smallest exponent for the x's is x to the first power here. Has to be x to the first, has to be the smallest, because they all have to have in common. And then finally m squared. So the point is we don't want to write this out for no reason. It is going to help us know what's going to be left inside of the parentheses. We're going to find out that the first term is going to have an a and an x left over, the second is going to have an m, and the third is going to have a squared x squared. When we reverse the distributive process and factor these out, we are now factoring out a squared x m squared, because that's the greatest common factor. So when we do that, what's left here? It's kind of like dividing by, it's exactly like dividing by axm squared. Will be left in this first term here. Well, a squared, two a's would cancel out, 1 is left. 1x would reduce out, so 1 is left. And m squared cancel out completely. All that's left is ax once we divide this term by a squared x m squared. And we could look down here and see that. Just like now we're gonna see that this middle term is going to be m, because that was all that was left here that wasn't in common. And sure enough, if we divide this middle term by a squared x m squared, a squared x x, m to the third, two of them cancel out, we got 1 in left. And finally the last term, if we divided it by a squared x m squared, we'd have an a squared left and an x squared. And sure enough, 2 of these would cancel out. 1x would cancel out, we'd have 2 left, the m's would cancel out, and we have a squared x squared. So this is our answer. We factored out the greatest common factor of those 3 terms, and this is what we have. One more. The greatest common factor. We're not going to write this all out this time. We know it has to be. First, let's go like this. Let's not even do that. We know we're going to factor something out, and what's left is going to be, in the inside, is something plus something. We're going to reverse factor out. To reverse the distributive process, factor something out. And it has to be 2, because this is 4 is going to be 2 times 2. A to the third, a squared, it has to be a squared. B to the fourth, b. I have to choose the smaller one, it's b. Z to the third, z to the fourth, it has to be z to the third. In the first term, if we divided 4 by 2, we'd have 2. If we divided a to the third by a squared, we'd have an a left over. B to the fourth divided by b, we'd have b to the third. And z to the third would cancel out. And here 2 and 2 cancel out. A squared and a squared would cancel out. B and b would cancel out. Z to the fourth is z to the third. We'd have 1 z left over. We could write all that out. I guess I prefer not to, but you can. I said I wasn't going to, and here I am writing it out. And we said we can take out a 2. We can take out a squared. We can take out a b. We can take out a z to the third. And sure enough, look what's left. The first term we said would be 2ab squared, b to the third, 2. I originally did not write this correct. It's b to the fourth. I need another b here. So 2a b to the third, that's what we had. And then here c is all we had. So everything seems to make sense. So the first part of our lesson is reversing the distributive process. We call that factoring out. Second part is using that and applying it to something, and really we're applying it to canceling. And in order to understand this, we first have to go through some rules, because we know algebra is about rules. When I have 3 plus 2 over 2, 3 plus 2 over 2 we know is 5 halves, right? And what we need to understand is when we have 3 plus 2 over 2, we cannot cancel these 2's out. Because if we do, now our answer is 3, right? With 3. And that's not the same as 5 halves. So that is illegal. We cannot do that. We can't just cancel out 2's when we're adding. However, when we're multiplying, we can. If we're multiplying up here in the numerator, we can cancel these 2's out, and we can prove that. 3 times 2 is 6. 6 over 2 is 3, right? So if we wouldn't have canceled them out and multiplied it out, we'd get 6 over 2, which is 3. We get the exact same answer if we cancel them out. because they become 1s, and 3 times 1 is 3. So it does work when we're multiplying. So if we're multiplying up here, we can reduce. But if we're adding up here, we cannot reduce. We can't cancel those 2's out. So when we have 6 minus 4, we can't reduce, because that was like our first example here. We can't cancel that out. So what we're going to do is we're going to factor out. Just like we did up here, we factored numbers out of the expression. Here it was addition, and we changed that addition to multiplication. This is being multiplied by this quantity. We're going to do the same thing here. We're going to say, oh, I can factor a 2 out of here. I can factor a 2 out of 6 and 4, and I would have 2 times 3 minus 2 over 2. Same thing. I just factored out 2. But the other thing I did is I now made this multiplication, and I know that in multiplication I can reduce these 2's out. My answer is 3 minus 2, or 1. I can cancel these 2's out. So when we're multiplying up here, we can cancel them. When we're adding, we can't. So here's another instance. I have 4 times the quantity a minus 3 over 4. Because I'm multiplying, I can cancel out these 4's. In fact, here's another strange example. I've got 3 times the quantity x minus 2 over the quantity x minus 2. Because this is multiplication, I can cancel out this whole quantity. And we're going to start using that knowledge to simplify, this will be our direction, some problems. The first thing we have to really do, and this will be the trick sometimes, is just identifying that there's something you can take out of here. You might look at this and say, well, that's as simplified as it gets, but it's actually not. I can't cancel these 3's out because this is addition. Remember we said if it's addition, that doesn't work. So what I can do is I can factor a 3 out of both of these two terms here, and I'd end up with 3 times the quantity p plus 1 over 3. I just factored out a 3 from 3p and plus 3. Now this is multiplication though, and so I can reduce, cancel out the 3's. So simplified, the answer is p plus 1. Here, another example, directions are simplify. I've got 3x minus 9x squared over 3x. I have to, first of all, I cannot cancel out this 3x here with this 3x because we've got an addition problem up in the numerator. But what I can do is I can look at factoring something out of these two terms. And what I'm going to factor out is a 3 and an x. That's the greatest common factor. I'm going to take out a 3x. So if I took out a 3x, it's like saying I'm going to divide both of these by 3x. This would be 1, right? 1 minus 9x squared becomes 3x. And that is still over 3x. And the advantage to that is I can now simplify. I can reduce, cancel out the 3x and the 3x. So my answer is 1 minus 3x. One more. 5x minus 25x squared over 5xy. You probably have picked up by now you're going to be able to factor something out of the numerator. I can take out a 5x. When I do, I have 1, not nothing, but 1 minus 5x. And in the denominator I have 5xy. And in the denominator here I don't cancel out the whole thing, but I can cancel out a 5x. The y is still there. So my simplified answer is 1 minus 5x over y.